So what I have here is open up an Excel spreadsheet, and if you're not familiar with Excel, you know, go to your Start menu, type in Excel. If you don't have Excel, I'll see what we can do. Maybe I'll make another video for you, but I still need you to watch this one so you understand the steps. And if you have Excel, it might be worthwhile to walk through this yourself. So if you open up another Excel spreadsheet, pause this video and type in the things that I have here. And if you're struggling with making column A a little wider, if you make it short like this, and you move your mouse over to the arrow, over the line here, double click, it will auto expand to fit your data. And you can type that data in and then hit play. Okay. So what I'm going to do here first is make sure I format my data. And what I have here in my axes are my units and uncertainties. And notice that I've got my units there twice. These uncertainties are determined in the same manner that we did in lab, in the precision lab. So you need to carry that forward. So anytime you have a unit, anytime you write a unit in your reports, it needs to be followed by, anytime you write a number, it needs to be followed by a unit and uncertainty. But for Excel to crunch numbers and to do some analysis, you need to make sure that those units don't appear here. So you wouldn't write 25 grams. You would write 25 and make sure that you have your units, 25 is not grams, 2.54 grams. Or this 25 actually represents Celsius, degrees Celsius. But if I type that in there, I wouldn't be able to crunch the numbers and graph in the way that I want it to. So I just want these numbers to stand alone, but have the units clearly available for me to do my analysis. And so you see I've got 3 placeholders here in my uncertainty. So what I really should have is 3 placeholders for all my data points. But if you remember back to the precision lab, I'd be using the scale to find this mass, and the scale only gave me, the best scale that we have only gave me 2 decimal places, or to the 100th place. But the uncertainty exists into the thousandths. It's plus or minus 5 thousandths of a gram. And so we need to model that and follow that through. So what I'll do is actually highlight those cells. And then what I'll do is right click and go to Format Cells. And the menu that pops up eventually, sorry, my computer seems to be running a little slower than normal here. Maybe because I'm recording the screen. What the heck? Okay, so this box popped open, this window opened up, and once I click Format Cells, and so here for number, I'm going to click on number instead of general, and change my decimal places. So right now I have set for 2 decimal places, but really I want 3. So I'm going to bump it up. It's going to add a 0 to that first cell, and sorry, not everything showed up here. So then I'll click on OK, and it updated all of those cells. So now I've got zeros on the end, which is exactly what I want to reflect this uncertainty. And so I've got my table set up. So what I need to do next is copy these cells. So I select those cells, hit Control-C, and move it somewhere over here. What then I'm going to type into these cells is mean and standard deviation, or SD. And so what I'll do is copy that, copy formulas or insert formulas. So if you've never done that before, let me show you how to do it. So fx, you should know from math class, stands for function. So I'll make sure I have the cell that I want selected, click on fx, and find average, or you can type in average here, right? So once you get to the average, click OK. It's going to ask for what numbers to average. And so if you click on this kind of gray/blue button, and then pick the data points you want, and then click this gray-blue button again, and hit OK, it's inserted the data point for me. And what all I'm going to do is, I didn't show you this trick. So if I hover over this cell, in the bottom right corner, my cursor turns into these crosshairs. I'm going to click my mouse, hold it down, and then drag to the right, and it's going to apply that same formula to my other columns and give me my averages. I'm going to do the same thing for standard deviation. So I'm going to type in fx. I'm going to type in STDEV, standard deviation, hit go, and see what comes up. So I'm going to pick the first formula, STDEV, and hit OK. And again, I'm going to pick my data point. So the same data. It needs the raw data, which is actually technically not raw data because I've calculated the change in the mass. So my raw data would have been my initial mass and my final mass. But this is the change. So this is the data I'm going to have it calculate the spread of. So it needs all the data points. It's not just the average. It can't calculate the spread of the average when that's one value, right? So I'm hit OK, and I've got a lot of decimal places here. And if we were to turn this kind of data table into me, it would show me that you don't know how to process it. So let me show you what I need you to do. I'm going to select those cells, right click, go back to Format Cells, go to Number, and on our raw-ish data, we had 3 data points. I'm going to go to 1 more because we're processing it. So it shows a little bit more precision. For example, if we were to take the number 1 and the number 2 and average those numbers, you'd end up with 1.5. But automatically you're thinking of 1.5, which is 1 more decimal place than 1 or 2 has. If we were to take 1.5 and round it so there were no decimal places, we'd be at 2, which is obviously misleading when the average is actually 1.5. So we have to make sure that we understand that we need to add more decimal places. So I'm going to go to 4 decimal places, hit OK, and it cleans up that table, which is great. Now let me show you how to graph that data. What I'm going to do is select these 2 rows, just my different temperatures, my levels of the independent variable, and the average values for them, not my standard deviation. I'm going to go to Insert, and I'm going to go to Graph. I'm going to go to a scatter plot. And what it's done is graphed these dots for my average values. And we've got a lot of space here. We've got all kinds of zeros here, but that's because of the number of decimal places I put in there. And you can adjust all of that by clicking on the plus here, or up under Chart Tools, you'll see another tab maybe, depending on what version of Excel. If you have questions, please come see me during Eagle Time. I'm happy to help you. So you could label your axes. You can go to Axes, More Options, and go through all these different things here, right? So you can change the range of your data value. So we've got 25 to 40 as my range, so maybe I want to go to 20, and 40 maybe is fine. Sorry, there's a lot going on with this. We can display units if we want. If we want a logs-based scaled or not. You can change your tick marks if you want them. You can put where you want your labels or your numbers. So those are all options that you have, right? So you can align them. You could put shadows. I wouldn't do any of that. You could change the colors. Again, I wouldn't do any of that. So, but when you saw that the axes changed, so now I'm between 20 and 36. You should add titles. You can type those in. So your axes titles, you can change your title up here. You can put data labels if you want. There are error bars, which is going to be key for us in a second. We have our grid lines there. You can put a legend, but this all represents mean, and if you indicated that in your title, that'd be great. We'll talk about what good format of a title is, and a trend line, even if you wanted to. So let's go and add our error bars. And if I just clicked on that, this is what I would get, which is that represents no data at all that we've calculated for a standard deviation. So let me walk you through how to add that. So you might be tempted when you click on this error to go, oh, it's a standard deviation, that's what I want. Well, if you hover over that, that looks like a mess. Because what it's doing is applying one value to all the data points. For example, look at the leftmost data point for 25 degrees Celsius. The error bars don't even cover the average value. So if you click on more options, you can go to error bars, more options, and when we say you should have directions of above and below. That's the plus or minus 1 standard deviation. You should have caps on both ends, and you don't want a fixed value. That's the problem here, is that it's giving the same value across the board. What you want to do, and you don't even want to click on standard deviation, because you still get that same mess. What you need to do is click on custom and specify value. And when you click on the positive error value, what you're going to do is select across the entire row of standard deviation. Excel is smart enough to know which mean to apply that value to. And for the negative error value, because it's plus or minus the standard deviation, you pick actually the same standard deviation value. What happened? Alright, so it's some mess up there. Okay. Let me do that again real quick. Okay. Okay. Wasn't picking that up. Hold on. Okay. Here we go. Let me fix this. I'll be right back. Okay, so I was having for whatever reason I was having issues. It wouldn't let me put them in both places. But what I ended up doing was just copying. So I just selected all of it, hit Control-C, pasted it into the negative value, hit OK. And then when I'm looking at my graph, and you might have seen that there were horizontal error bars. I just clicked on them, hit delete, and this is what I'm left with. Hit delete on the keyboard, okay? And this is what I'm left with. And if you update your means and your axis titles to reflect really what they're supposed to, so look at, I will be passing out a sample IA, so you can look at those, and what the title should be. You will have your graph. And again, this is just a descriptive analysis. But looking at this graph, you can see that maybe these two groups right here are not significantly different, which is a really important word. Significantly different, or statistical significance, refers to the use of hypothesis testing. And I've not shown you this, and I'm not going to show you this in this video. That's going to be for another homework assignment, not for next class. So what I'm going to have you do is try to describe this, right? So if you look at this, you can see that these two data points, because the error bars overlap with each other along the y-axis, there's not likely a significant difference between these two temperatures. But there seems to be a difference between these two groups and these two groups, right? So something's happening right in between these two data points that causes the rate of the change in mass to increase, and then it kind of looks stable, right? And so what we can do is try to figure out that relationship by adding a trend line. Now that linear trend line is probably not what we want, because it doesn't look so linear to me. But I wanted to, I hope you saw what I just did there. Click on the graph, the plus sign, trend line, arrow, more options, more options, and display the r-squared value on the chart. And so my r-squared value is 0.71, which is pretty good. I mean, it's between 0 and 1, and the closer is to 1, the stronger of a correlation it is. But it may not be linear, right? So we might want to say exponential, which if it's exponential, gives us something a little bit better. It's logarithmic, it's even better than that. And polynomial is even better, right? So I think that that's really going to be the best model. Yeah. So this is a polynomial relationship. I'm going to delete my linear line here, I think, if I can. Yeah. And so that's going to be my best representation of that. And so what you can also do is display the equation. And so you can see that that's the mathematical relationship between these data points. Okay? That can be really useful to you. It may not be, but all we know that is that we should look closely at if there's a difference between these two groups and these three groups. There's not likely a difference between these two and these three within those groups, but there is likely a difference between this group and that group. And that's what an ANOVA test will allow us to do. All right, I'm going to pause it there and see. And again, I wanted you to follow along and see if you can get through this. Okay? Thanks.